So today, well, this week it's all about graphing. Today, tomorrow, and Wednesday, well, Wednesday is the school SAT day, and I will not be here for class because I'll be proctoring the SAT. So today will be the introduction. Tomorrow and Wednesday will be all just practicing. Now, there are two parts of the graphing here. Today, tomorrow, Wednesday will be about the reciprocal graph, which is this. Okay, it's going to be 1 over x. We'll draw the graph, and then just like before, we will do all the transformations, moving left, right, up, down, vertical or horizontal stretch. Okay. Now, then on Thursday and Friday, we'll learn something called the rational graphs, which looks more like the stuff that you did last week. All right, so that's the announcement. Yeah, so Thursday and Friday, we'll do something called the rational functions, which is like what we did last week with all the factoring, x plus 2 times x minus 5. The graph will be a little bit more complicated in that case. So this is the simple stuff. Thursday and Friday will be more interesting. All right, now, so here's something I want to show you here. Now, this is 1 over x, okay? So the number that we're going to put in will be in the denominator here, okay? Now, let me give you one simple, easy number. If x is equal to 1, what's y? 1, right? Now, I'm going to leave a little space, okay? Because I'm going to put something in between 1 and -1. So just go ahead and leave a little bit of gap. What about 1 over -1? -1, right? So now we can go ahead and plot these 2 points. And these two will be the main points that we will show. All right. Now I'm going to ask you this. What about if x is 2? What's y? Y will be 0.5 or 1/2. Because x is 2, x is in the denominator. So if x is 2, then the y value will be just 1/2. Okay. What about x equals to -2? -1/2. So we will have -1/2 right here. Okay. Now I'm going to put 2 numbers right here. What about 0.5 and -0.5? What is 1 over 0.5? It'll be 2. 1 over 1/2, it's 2. Or you can think about 0.5 goes into 1 2 times, right? So if x is 0.5, the y value is 2. Okay. And then what about if x is equal to -0.5? -2. So what I want to first show you is that a graph is simply a representation of all the points on the graph. So now, this is how we draw the graph. Okay. This is how we draw the graph. And I hope you can spot out something. If you did not spot it out yet, that's fine. What if x equals to 0? Undefined. Ooh, that is undefined. 1 over 0, it's undefined. Okay, remember what we did with all the restrictions? We said we don't want the denominator to become 0 because it will become undefined. And how does it show on the graph when it's undefined? And this is why I use red color in this case. That becomes our so-called vertical asymptote. Now, my understanding, I'm not sure how accurate my understanding is. I heard I learned from some students that you all learned about asymptotes back in 8th grade. It's fine. It's fine. I totally did not expect you to know what it is. Now here's the thing that I want to make clear. Ready? After years of interacting with students in math, I would share some observations with you, and that is a lot of people, they are confused with the concepts of asymptotes. Now we will have two asymptotes. We will have vertical, and we have horizontal. And a majority of the students, they do not fully understand the difference between vertical and horizontal asymptotes, because a lot of times they just focus on how to get it right, but they just one step too short to ask that question: what creates these asymptotes? So first, I want to show you that vertical asymptote, it's created because of the fact that some x values would make the function undefined. That's the sole reason why we have vertical asymptote, is because something could make the function undefined. And I would also want to share with you that horizontal asymptote means something quite different. So please do not just reverse the orientation of the vertical asymptote and say, oh, that's what vertical asymptote is, and that should be what horizontal asymptote is as well. That is not quite true. We'll talk about horizontal asymptote in just a moment. But first, is there any question with the shape of the graph? Or is there any question you want to ask? If not, I'm going to start. I'm going to ask you a few questions. Oh, okay. We will talk about that. Actually, I can tell you right now, the center of rotational symmetry. So it's like, which point does it rotate? Just like our cubic function, we have that term in cubic function and cube root function as well. And it will be 0, 0 right here. Now, I'm not going to plot it because it's not really a valid point, but the center of rotational symmetry will be right here. Okay, so you rotate and hold this point still, and then you can rotate the graph and rotate for 180 degrees. It will look exactly the same. So that's why the default, it's going to be 0, 0. Any other question? Will the graph ever touch the vertical asymptote? Never. Okay. So I would also include a little bit of notes right here. It is going to be never touched by the graph. That's one characteristic of vertical asymptote, is the graph would never touch. The graph would never touch the vertical asymptote. Now, and I'm not going to pose this question. I'm going to show you a picture with the question. Okay. So again, the tiles. So it was, if you want to buy the tiles for extra credit, it would be like this. So 79 cents per square foot. And if it's 2 by 2, that means there'll be four square feet. So you do the math. Now I'm going to type in a horizontal asymptote on Google. I'll show you a picture, and I will ask you a question. Okay, we will see something like this in the future. And my question for you is that, could the graph touch across the horizontal asymptote? Could the graph cross or touch the horizontal asymptote?
Yes.
We'll say, yeah, because you can see right here. Okay, right around close to 2. When x is close to 2, you can see how the graph would cross it. So at the very beginning, I want to make sure you have a clear understanding that is vertical asymptote is something that you would never cross because it's undefined. Horizontal asymptote, it may cross. Not necessity, but it may. We will investigate later on, okay? But I just want to make sure that you have this early idea. Vertical asymptote cannot be crossed because it's undefined. Horizontal asymptote could be crossed. Okay? Are we good?